طيب يا شباب بسم الله الرحمن الرحيم. So last time يا شباب we were talking about the entropy rate balance for control volumes, and then we defined the entropy rate balance equation and showed you how you can use it for using an example. Okay, so today I will talk about isentropic processes. Okay, and then we'll see how the equations change when we have isentropic process. Okay, so this is isentropic. Who can tell me what is isentropic process? يلا شباب. What is an isentropic process?
No change in entropy.
So isentropic process is a process where the entropy
It's constant.
does not change. That means S1 equals to S2 if you have, let's say for example, process from 1 to 2. Okay, so the entropy is constant or does not change. طيب, let's see how this applies when we talk about, for example, ideal gas model. Okay, so we'll take it step by step for different cases. So the first one is for ideal gas model. And for ideal gas model يا شباب, if you remember, the equation we defined is the following. For the entropy change, we said S2 at T2 and P2 minus S1 at T1 and P1 equals S naught, right? So this was one of the equations. S naught at T2 minus S naught at T1 minus R ln P2 over P1. Okay, so this was one of the equations. Remember, for these different cases we were defining always two equations because we had two TDS equations, right? So we were defining the entropy change using two different ways or two different equations. The one from this one is noticed, the one in the table tabulated for the ideal gas probability tables, which is A17 and forward. So for isentropic process, so for S1 equals to S2, what happens? So if S1 equals to S2, so this term is what? Right, above. So this here becomes equals what? معي يا شباب? Do you hear me?
Yes.
في أحد مو سامعني؟
Zero.
اسمعك.
So yeah, so this one is 0, right? So if S1 equals to S2, so S2 minus S1 is 0. So you are left with, so this, the whole term equals to 0. Then we can have S naught minus S naught at T1 equals, or خلينا نقول S naught at T equals S naught at T1 plus R ln P2 over P1. Okay, or in other ways I can also solve for what? I can solve for the pressure, right? So P2 equals to P1 exponential, right? If you take the exponents so that you can take the pressures, then this will be S naught at T2 minus S naught at T1 divided by R here. Okay. So if you have a question with isentropic process and ideal gas, this equation applies. Okay. If I ask you what is the final pressure, you can find it using this equation, right? And using S naught from the tables, and then you can evaluate to find final pressure, for example, here. Also, يا شباب, there is a shortcut or special case for air. But before we move on, is this clear here يا شباب? Is this clear?
ايه دكتور.
This is clear, huh?
Yes.
Okay. طيب air, the special case of air, okay, air as ideal gas. So if you have a problem and I give you air and tell you consider air as ideal gas and I tell you it's isentropic process, if you go to the tables, ya shabab, if you go to the tables, you will see that if you go to table A17, for example, you will see that you have this note and also you have something called PR and VR. Okay, PR and VR. Remember, this one is different from this is not the same as reduced pressure and volume. Okay, so if you go to table A17, you will see something called PR, something called VR. What are these? I will explain it now. So this is not the same as the compressibility chart and reduced pressure and volume. Okay, so this is not the same. Okay, so do not assume that's the same as the reduced pressure and volume. This is different. But what are these PR and VR? I'll show you now. If you look at this equation, let's rewrite it in terms of P2 over P1 equals. So since this is negative minus, so I can rewrite it as S naught T2 over R minus S naught T1 over R. So exponential of difference of two functions is basically what? The exponential of the first one divided by the exponential of the second one, right? هذه منين جاية? I just rewrote this one as exponential is not T2 over R minus is not T1 over R. So this one equals to this one. This is math, يعني nothing new here. Okay? Now, this term here, this exponential of S naught is what I call, in this case, this is what I call PR. In this case, this is PR2 and this is PR1. Okay? So basically here, PR2 and PR1 is a function of what? A function of temperature. Okay? So if I give you a problem where you have an ideal gas, air as an ideal gas, you can immediately, if you want to find, let's say, if you have the first pressure and you have T1 and T2, you can just go to the tables and find what is PR at T2, what is PR at T1, okay? And then if you have P1 or P2, then you can find the other pressure. Okay, Shabab? Just to clarify, let me share with you the tables quickly to show you what I mean. Yes. So if you see here, ya shabab, this is it. So ideal gas properties of air. You notice you have PR and you have VR. So P2 over P1 equals PR2 over PR1, and PR is a function of temperature. So at any temperature, if you have state 1, let's say at 200 Kelvin, then you can just get directly the corresponding PR. Okay, so this is only for, shabab, this is only for air. Because if you go to the other tables, if you go to the other ideal gas properties of N2, you don't see that. We don't have this, the PR or VR. Okay? So that's why it's only tabulated for air. Any question here? Any questions about this one?
واضح يا دكتور.
Okay. It should be straightforward. طيب, what about the VR? What is VR? Okay. For ideal gas, we know that PV equal RT, right? And we know V, I can rewrite V as RT over P. Okay, so if we actually use that and write, for example, V2 over V1, which equals RT2 over P2 divided by V1, which is basically times P1 over RT1. Okay. So basically this is equals to, so if you replace it now, if you replace this one here, you have, let me put a different color. This one here, P1 over P2 is what? PR1 over PR2. Okay, so this equals to RT2 over PR2 times PR1 over RT1. Okay, and this equals to VR2 over VR1. Okay, so what is VR here in this case? VR equals RT over PR. This is basically VR. أي سؤال هنا يا شباب؟ Any question? Any questions here?
واضح.
Okay. إذا في شيء مو واضح يا شباب, please stop me, okay? Okay. For constant specific heats, for constant specific heat, basically I can rewrite my equations. This is from before, يعني 0 equals Cp ln T2 over T1 minus R ln P2 over P1. This is exactly from before, so these are the two different equations. You have Cv ln T2 over T1 plus R ln P2 over V1. Okay, so yeah, so basically for what is Cp here? Just a reminder, Cp is, I can use the specific heat ratio. So we have K equals Cp over Cv. Just a reminder. So I can rewrite Cp as Kr over K minus 1, and Cv equals R over K minus 1. Okay, and then if I use the ideal gas relations along with these, I can find relations like that. T1, T2 over T1 equals P2 over P1 over K minus 1 over K to the power K minus 1 over K. Shabab, this is just a reminder from before, yeah. Okay, V1 over V2 K minus 1. Yeah, anyway, so, and this you can also derive it, shabab. So for isentropic process, we derive this how? Shabab, for isentropic process, from this equation here, if you solve for this here and this, you can find these relations. Okay, so you can use these equations to derive these here. Okay, so I'm just giving you the final answer in this case. All right. So again, these equations apply for S1 equals S2, and K is constant for all of these cases. All right. Any question here? So I'm trying to go a little bit fast so that we try to finish. We don't take much time. But any questions? It's also important to understand. So as a summary, what did we do? We were talking about isentropic process. So we have seen some of these relations before, but for isentropic process, we have S1 equals S2. So if you apply that for ideal gas, for example, we get these different relations. And from the tables, from the ideal gas tables, I can use specifically for ideal gas, I can use, or air, sorry, I can use what we call PR and VR, which are defined like this. Okay, so we can use the tables to evaluate properties. Also for a constant specific heat and isentropic process, I can use these also relations. واضح? Clear? The last point I want to mention here is the polytropic process. Polytropic process. If you remember, for a polytropic process, we have P V to N equal constant. Okay. And for isentropic process, ya shabab, for isentropic process, an ideal gas, so let's put it this way, for isentropic process, an ideal, is it ideal gas or? Yeah, an ideal gas. Okay, or not necessarily ideal gas, it's for a gas. What we have is PV to K equal constant, and K is constant. Okay, so K is basically the specific heat ratio. So if I have isentropic process, so this is for isentropic process. So for isentropic process, K equals n equals k. N equals k for isentropic process. And if you remember, so if we have n equals to 1, this is isothermal process. If n equals 0, this is isobaric. And if n equals plus or minus infinity, this is isometric. Okay, so this was just a quick summary using the previous relations we have seen before, but we applied it for isentropic process. Any questions here? Any questions? ما في أسئلة؟ No questions? شباب معي؟ يعني واحد يقول شيء عشان أحس يعني. طيب. Okay. طيب, let's take example quickly for air as ideal gas and for isentropic process. Okay, let's see how we can apply these equations. Okay. Give me a second يا شباب. I'll be back. Inshallah, I will summarize. No problem. Okay. So, اسمعني؟
نعم.
طيب. So, let's take this example. So, I have air is going through isentropic process. All right. So the initial state of this air initially it was at P1 equals 1 bar and T1 equals 300 Kelvin. Okay. Until a final state of T2 equals 650 Kelvin. Okay. So the question is, find the final find P2, which is the final pressure, employing the ideal gas model and A. So we have two approaches. I want first approach to find it using PR info. Okay. The second part is to find the P2 using K equal constant and evaluated at the average temperature. Okay. So again, the question is, I have air, it's going through isentropic process from P1 T1 to a final temperature T2. The question is, find the final pressure using the ideal gas model and the PR information, this first approach, and the second approach using the constant specific heat ratio evaluated at the average temperature. So how can we approach using the first how can we use the first approach? So part A. ها شباب يلا. So I told you this is ideal gas, and I told you it's clear. What's the relation I should apply here?
B2 over B1 equals BR2 over BR1.
طيب P2 over P1 equals PR2 over PR1. So P2 equals P1 times PR2 over PR1. طيب, how can we find PR? So we go to table A17 at شباب at T1 equal 300 Kelvin. What is PR1? So let's check the table. At 300 Kelvin here, I have
1.386.
1.386. So go back here. 1.386. What about T2? 650. PR2. So 650, let's see, where's 650?
21.86.
So exact. So it is
28.
no. It's 21.86, right?
86.
Yes. So it's 21.86. خلاص, that's it. So P2 equals P1 اللي هو 1 bar. I'll use bar, is fine. Times 21.86 divided by 1.386. And if you do this, you find the final pressure 15.77 bar. Okay? Easy. Very straightforward. How can we use the second approach? Using the constant specific heat. So this is isentropic with K equal constant. خلاص, isentropic K equal constant. عندنا relations clear. Okay, so I have T2 over T1 equals P2, right, over P1 K minus 1 over K. Okay, so then I should flip this one, right? So if I need to find the pressures, so I just take the power, يعني, you know how to do math, right? So it's gonna be P2 over P1 gonna equal T2 over T1. It's going to be the opposite here, K over K minus 1. Right? So P2 equals P1 times T2 over T1 K over K minus 1. طب أنا قلت لكم evaluate K at the average temperature, or take the average K. So what you can do is, so at 300 Kelvin, what is K? We go to which table, ya shabab? So this is also evaluating properties skill. So we go to, let's go here. So we go to table A2, no, not A2, it should be, yeah, A2B, yes, at various temperatures, here. So I have 300 Kelvin, I can find what? K here, and then at 650, I can find K here, and then take the average. Some other person will say, no, I will take the average temperature, 300 plus 650 over 2, and then take the K. That's also possible, but here, since we have it directly evaluated at 300 and 650, it's easier just to take it here and then take the average later after that, okay? So let's go back here. So at 300 K is 1.4, okay? And at 650, K is equal to 1.37. So basically, K average
1.385.
1.39. Okay, just approximate. خلاص. So ولا عشانك يا شيخ 3.85. Okay, that's it. So what we do is P2 equals P1, which is 1 bar. We have 650 over 300 over 1.385 divided by 1.385 minus 1. Okay, and then the final answer is تقريبا 15.81. Okay. So since this is an ideal gas,
دكتور عندي 16.14.
Okay.
16.14.
Are you sure?
Yes.
Did I do a mistake here? Okay, I'll take your word for it. 16.14.
14.
Okay. Okay, you see they are close, so this approximation is not bad. Okay, any questions here?
يا دكتور
Yes.
الحين التيبل A17
أيوة.
وحدة
صوتك يقطع.
التيبل A17 البي ار ما له علاقة بالوحدة صح؟
ما لها وحدة.
اي تمام بس اتأكد.
إيه. الوحدة تنكتب في التيبل يعني. If it doesn't have units, it means it doesn't have units. Okay. Any other question? Let's take another example quickly. Let's take another example. Example 2. I have a rigid tank like this. So it initially contains خلنا نشوف. Yeah, it contains air. Okay. And so this is rigid, well insulated tank. Insulated tank. Okay. So the initial state of this air inside the tank is M1 is 5 kilograms. Okay. P1 is 5 bar and T1 is 500 Kelvin. Okay. So what happens is I open a small hole, so air started leaking slowly. So slow leak. Okay. From this opening, so slow leaking until the final pressure. So finally P2 equals 1 bar. Okay. So it was leaking until the final pressure decreased to 1 bar. So using the ideal gas model, or employing the ideal gas model, okay, what is the final mass? Final mass and temperature. So basically I need M2 and T2. What is the final mass and what is the final temperature? Okay. So how can we approach this problem? I'll show you the procedure, then I can give you the final answer. You can work it out, since we have only like 6 minutes left. Alright, Shabab. I told you this is ideal gas. Okay. So you can immediately apply what? And be clear, this is ideal gas. I can apply the ideal gas equation at any state, right?
Yes.
So at the final state, I have M2 equals P2 V2 over RT2. Okay? Right? So let's see what's given here, what's known, what's unknown. I have P2, I don't have T2, and I don't have V2. What can I have? What can I find here, Shabab? What do I know about this one?
I think you can find V2.
No, I have P2 and P2. I need
V2.
Huh?
V2.
V2, you mean?
Yes.
How can I find V2?
I think by the equation V2 equal V1, but with N.
لا بكل بساطة what is V2? V2 is same as
V1.
V1 صح? This is the rigid tank.
Rigid tank, yes.
Yes. يعني don't complicate the problem. So we have the same volume. So what I know now is V1 equals V2. Okay? So, and then how can I find V1?
V1.
So عندنا exactly from
the
state 1, so M1 equals P1 V1 over RT1. So I have T1, right? I have P1. I have M1. I can find V1. So this is done. Okay? Clear?
Clear.
So let's see here. Now the question is, how can I find T2? So now this is what's left. How can I find
The equation 2 over T1.
Which equation?
For constant K.
I did not mention anything about this.
Okay.
I did not mention anything about this. Okay, so what we can do, okay, so this is well insulated tank, صح? So if we write the entropy balance يا شباب, so this is entropy balance. We have dq over T plus sigma or entropy generated. Okay, so if we look at this, this is well insulated tank, so I don't have any heat transfer. So this is 0. And I did not tell you and there is any entropy generated within the system. Okay, and I'm telling you this is ideal gas, so this is ideal situation, so I can also consider this equals to 0. That means delta S equals what?
0.
0, which means this is what type of process is this? I can consider, yes, I can consider it isentropic process. Since this is isentropic process, that's it. I can apply what? And this is air, and this is ideal gas, and this is isentropic process. I can have P2 over P1 equal PR2 over PR1. So I have this equation. Okay. From here, I have P1, P2, I have P1, صح? I have the T1. From T1, I can find PR1. So what I'm missing what?
PR2.
هذا التيبل هنا يا شباب. A17. Okay. So here, so I have T1. From T1 I can find PR1, and I already have P2 and P1. So if I find PR2, I can go back and reverse and find what? T2. فهمت الفكرة? So this is opposite kind of. So from here I find PR2. I will give you the final answer here is 1.6822. Okay. Then at PR2, I can find T2 as 317 Kelvin. So you might need to, this is all from table A17. You might to do maybe some interpolation, okay, to find T2. خلاص, here we find T2, go back and find M2. All right, so I'll give you the final answer for M2 is equals 1.58 kilograms. Okay, so you can see, Shabab, where can we use the second law of thermodynamics here? Okay, it's important and can give us a way to evaluate properties and solve problems. Any questions here? Any questions?
واضح يا دكتور.
So please solve the homework practice problems that I give you, homework 8 يعني. مو عشانه يعني you don't have to submit it and you shouldn't do it. It's important to practice the problems يا شباب. Okay, so we are left with one last topic inshallah يا شباب, which we'll try to cover next class بإذن الله تعالى. Okay, and then hopefully maybe I can give you one quiz on Thursday. Any questions? Any concerns?
دكتور.
Yes.
روح توضح.
بس لعنا الدرس السابق يمكن أطول شوي.
إيه مو مشكلة. أحد عنده سؤال على هذا يا شباب ولا لا؟ إذا ما حد عنده سؤال خلاص you're free to go.
دكتور بخصوص الكويز إذا ممكن تخليها لأحد.
ما في كلاسات الآن ولا فيه؟
الأحد الجاي
إيه
أتوقع في.
خلني أتأكد. الظاهر يعتقد إنها، خليني بتأكد بس لأنه هي تعويض الظاهر على الشيء في الناشونال داي أو شيء زي كذا، يعني different days. اوكي
طب يعني إذا في كلاسات ما عندك مشكلة تأجل.
انا افضل انه we finish this week and that's it، يعني حتى اريح لكم بعدين ما تشيلون هم قدام، خلاص ذاكرون قدام، يعني don't have
سؤال.
to. اوكي
دكتور الفاينل متى؟
فاينل موجود في السيلبس، هو حسب
21
لأن في السيلبس شيكت قبل شوية اللي في
لا في
البوك هم
الريجسترر، هو حسب الريجسترر. يعني شيك مع الريجسترر
طيب يا
الموقع.
دكتور،
يس
الحين الفاينل بيكون فيه تركيز على آخر تشباتر ولا راح يكون كومبرهنسيف، يعني ما راح تفرق؟
الاختبار زي ما هو واضح في السيلبس اتس comprehensive. اكيد بيكون في تركيز على النيو ماتيريال يعني اللي ما اختبرنا عليها، بس برضو انتم عارفين انه حتى النيو ماتيريال you're
جات
gonna
من
use
اللي قبل.
calculating properties, you're gonna use maybe first law يعني everything, so everything is included يعني.
يا دكتور
yes
الحين في الشابتر الماضي في الكوز كيف أقدر أفرق؟ يعني أحيانا ما يكون السؤال واضح، هل الحرارة هل هي كولد، هل هو بمب انجن، ولا يعني تلخبط ما تدري شو، ولا هيت انجن.
انت لازم تفهم المبدأ حق كل ديفايس او كل سايكل.
والله كلها، لكن إذا جاء في سؤال كذا تلخبط ما تكون واضح، ولا إيش فكرتها كلها عارفها؟
طيب إذا أنت عارف الفكرة معناته أنت لازم تربط في شيء، لازم تربطه عشان تكون واضح. يعني أنت تقول عارفها كلها بس إذا قريت تخربط معناته ما أنت فاهم 100%، يعني في شيء مو واضح في مخك. فهمت قصدي؟ فأنت لازم تربط هذا الشيء اللي مو واضح. دائما أنت عندك شيء اسمه cold reservoir وشيء اسمه hot reservoir. هذه واضحة؟ لما يكون عندك
إيه.
cold وhot، الهيت اللي تروح للكولد او تطلع من الكولد هذا كيو كولد من الاخير. يعني اي شيء، اي هيت تروح للكولد ريزرفوار او تنأخذ من الكولد ريزرفوار للسيستم او من السيستم للكولد ريزرفوار هذا كيو كولد. اي هيت تطلع من السيستم للهات ريزرفوار او من الهات ريزرفوار للسيستم هذا كيو هات. خلاص اذا فهمت هذه صدقني ما بتخربط، لانه بيجيك اي سؤال بيقول لك والله كذا كذا كذا، هنا هذا was هيت بامب، خلاص تعرف انه الهيت بامب الهدف انه heating something. فلما قال لك والله I heat a room، خلاص الروم هذه هي الكولد الهات ريزرفوار، معناته اي كيو رايحه للروم ولا بتناخذ للروم هذه كيو هات زي كذا، يعني based on this.
طيب دكتور، بعض الأسئلة ما يذكر شيء، إذا ما ذكر شيء معناته أنه هيت انجن.
مستحيل ما يذكر معلومة تدل ان هذا كولد وهذا هات، والكيو يا رايح للكولد او من الكولد او رايح للهوت او من الهوت.
يعني مو لازم يقول اسم شو اسمه الاسم مثلا افهم انا من السؤال.
ايه مو لازم، هو قاعد يقول لك انا I'm heating a room ولا I'm having AC. AC is what? Is refrigerant. ولا مثلا heat engine، خلاص this is a heat pump. ولا I'm producing power. This is a power cycle. So this is يعني should be clear. واضحة ولا لسه يعني؟
ايوه دكتور.
زي ما قلت لك انت لو تفهم الاجزاء بالضبط حقت السايكل، انا عندي كولد ريزرفوار منفصل عن الهات ريزرفوار، ما هو نفسه ترى. It's separate. الكولد ريزرفوار is separate from the hot reservoir. اذا فهمت الاجزاء حقت السايكل خلاص عندي سيستم وعندي هات ريزرفوار وعندي كولد ريزرفوار بس. الحين اللي يختلف وشو؟ انا استخدم work عشان heat something or cool something, or I'm using heat to generate power. This is it. يعني these are the different options you have. فإن شاء الله يعني واضح.
ايه باذن الله يا دكتور. لا انت.
ممتاز. خلاص اوكي. بالتوفيق. يس.
درجات اختبار تشابتر 5.
قصدك كويز 5؟
اي يس.
والله انه لسه يا شيخ ما خلصتها، لكن ان شاء الله بحاول ارفعها
ما
قريب.
تقصر ما تقصر.